All right, so I'm going to go through the 2023 problem questions of recursion and finance here. So the first one we've got here, though it's not the lowest of percentages here, but only 55% correct. The important thing is when you have to show recursively the calculations determine the balance after 2 quarters. So this was a formula for quarters. So you must show all working out. So you've got to say like A1 would be 1.016 times the one before, which is 30,000. Then minus 1515.18, and then you get your answer. And then you have to show the next one, that A2 is 1.016 times that answer that you got. And so you must have all of this written out, otherwise you will not get your 1 mark. So it's really important. You're going to lose an easy mark if you don't show recursively. Okay, the next one, it says, so obviously this, Arthur borrowed a 30,000. It was in a loan, okay? So up here, should have probably read all that. But anyway, the final payment required will be slightly different from the earlier payment. Determine the final payment. So we should hopefully know by now, when we're trying to find the final payment, what you want to be doing is you actually want to find what the final value would be if you got to the end of the loan paying all those payments that you'd pay, and then you want to adjust it. So this is what we've been doing like the whole time. So first of all, I want to know when I got to the end of the loan, how much what is owing. So if you have a look, this loan was going to go for 6 years and he was going to pay it quarterly. The interest rate was given up there at 6.4. PV was he borrowed 30,000, so that's a positive. And he was making these payments. So we know that the last one is going to get adjusted. This is what we're trying to find. So he made payments, so they're negative. And this is what I'm saying. When you do final payment, you want to check out what this says. And obviously, because it was quarterly, this was 4. So you pop that in and you end up with 0.14. So when you have a positive value means the bank needs to give you that money. So bank technically owes Arthur 14 cents because he kept paying all those payments. So instead of owing him 14 cents after all those payments, they said no. So the final payment, instead of you paying the normal payment, they'll say, we just want you to pay the normal amount, but minus the 14 cents so that we're all square when we get to the end of the time. So we'll do that and we're going to minus the 14 cents. So he ends up with, so it says determine the value of the final payment, round to the nearest cent. So it's going to be 15.04. Okay. So that's how we do that one. Sorry, I put the wrong number there. That should be 15. Okay, so we've got a couple of questions in this 6. So just to remember, this is an annuity, and he that provides him. So he receives these payments. So that would be a positive payment, and annuity he invests, that would be a negative PV. Now, just be careful here. Though it wasn't a problem, but I just want to make sure. They said the interest rate for the annuity is 0.42 per month. So because that's per month, that's the monthly rate. So the actual the per annum rate would actually be 0.42 times 12, which we know is also the I in your finance solver. So just be careful. In finance solver, you'd have to put 5.04. But anyway, it says up here, so this question B was not done well. It says using the table of values, complete the next line of the amortization, write your answers in the space provided. All right. So he's receiving payments. So he's not gonna, they've told us that he's getting 3973. So I'll put that in there. Now, we've got to work out a few different things. Now, this interest amount is, so we often say I'm just going to do it down here. Well, we can say the interest amount, I'll put it here, is normally the rate divided by PPY over 100 times the balance before. So in this instant, it would be, I'm trying to find it, so it would be, now they've already, when you do the rate divided by PP4, you could just use that. That's what that is. This is actually R divided by PPY, yeah? So I'll do that. So I've got 0.42, but I've got to divide that by 100, and I'm going to times it by the balance before. So before was that number, so the 597087.90. So I do that, and I end up with what I'm going to pop in here. So I end up with 2507.77. Now I've had a look. That makes sense. It looks like it's going down, and mine's gone down as well. So I'm happy that I don't look like I've gone crazy in that answer. Okay. Now the principal reduction. Now remember, so what they did is they get given this amount. So this comes back out of the bank, but because their account actually made them money, their account won't drop by that full amount because we'll use the interest up. So if you do that 3973, you minus the interest that the account earned for them. So really, it's only actually going to go down by that difference, which ends up being 1465.23. And once again, you can see that looks good. It looks like it's following the pattern of getting more, to getting, the principal reductions getting a little bit more. All right. So then obviously the balance is, when you're trying to find the balance is going to be this number minus that number there. So when you pop that in, 57622.67. Okay, so you probably just need to have a couple of these examples in your reference book if you're not very good at the amortization table. So this interest formula, that's this. So you would always, if you need to calculate it, sorry, I probably should have written balance before there. And that's how you find it. All right, so that was not done well. Now it said write a recurrence relation. So we know we got recurrence relation. This is an amortization or annuity that you're receiving payments. So you should go to your formula sheet and you'll see that the formula sheet says, all right, you need to write your VO and you also need to write this rule and minus the payment. Yeah. So if you have a look, we need to calculate that, and we can already see the payment up here. So we don't need to, we don't need to calculate that. All right. So I'm going to do over here, I'm going to work out this R, which is, if you look on the sheet, is the rate over PPY over 100. Okay, so if you look at that's 1 plus, you can do, once again, we already know that's 0.42 divided by 100. So you end up with 1.0042. So now I can write the recurrence relation. So VO, it originally costs 600,000. And the VN plus 1 will be the R value, which I just worked out, times VN minus the payment, which we know is, they told us, is always going to be 3973. So there's my recurrence relation. So the amortization table on 11 shows the balance of an annuity reduces each month. If the balance of the annuity remained constant, so if the constant, it stays the same, what is the name given to that? So an annuity that never changes in its final value or its PV, that means it's a perpetuity. You're only using the interest. So this one's a perpetuity. Now it seems in both exams, both the short answer and the multi-choice, that perpetuities have come up in terms of problem questions. So I think you really should be getting a good understanding of what exactly a perpetuity is. So remember, if you think back, it had some letters or something where it said PO was A in a perpetuity, but if PO, say that's say they said PO, but it was VO. If VO is A in a perpetuity, so is V1 would equal A, V2 equals A, and V3. That was the question, another trappy question. So I really want you to understand what a perpetuity is.